Hello students, here are some questions based on greatest integer function and fractional part function, which normally students find difficult to solve. Look at the sixth question especially. So we are going to solve all these questions, but before that we'll start with the theory. Now here is the graph of the greatest integer function. You can see it is a staircase type graph in which we have steps. You can see the domain here is x belongs to R, which means for any real x we can get the value of y. And the range is y belonging to z. That means the answer will always be an integer. So greatest integer x is basically greatest integer less than or equal to the number x. Now here, if you put in integer, you will get answer as an integer also, the same number. As you can see these examples, if you put 5, you will get 5 as the output and so on. Now if the number given as input is not an integer, for example it is 5.13, then the answer will be 5. Now this is the greatest integer less than 5.13. Similarly, in case of minus 5.13, the integer just below this is minus 6. So that is what we get the answer as. Similarly, for 2.35, answer will be 2. And for minus 3.15, the answer will be minus 4. If we look at the number line, the first integer to the left of the given number is the value of the greatest integer function. For example, look at the number line. 5.13 is here. So 5 is to the left, first integer to the left. So 5 is the answer. Minus 5.13 is here on the number line. So the first integer to the left is minus 6. For 2.35, which is here, the first integer to the left is 2. And similarly, for minus 3.15, which is here, the first integer to the left of it is minus 4. So this is a graphical way of understanding things. Now, secondly, if we are given greatest integer x is equal to 1, we should be able to get the answers for x. That is, it will be 1 closed to 2 interval, that is 1 less than equal to x less than 2. This is the answer or solution to the equation as greatest integer x equal to 1. You can see on the number line also as shown here. Similarly, if greatest integer x is equal to 2 is given, then 2 less than equal to x less than 3 is the answer. So we can see what will be the case if greatest integer x is equal to n in general. We can say that x will belong to the interval, closed interval n comma n plus 1 open, right? That is n is less than equal to x, which is less than n plus 1. Now, if we are given greatest integer x is greater than equal to 1, now this will mean greatest integer x is either 1 or greatest integer x is 2 or it is 3 and so on, because greatest integer of x is always an integer. Now looking at them one by one, greatest integer equal to 1 will give you answer closed 1 to 2 open interval. Greatest integer x equal to 2 will give you closed 2 to 3 open, and greatest integer equals to 3, 4, 5 etc. up to infinity will give you closed 3 to infinity. Now taking the union of all these, you get the answer as x belonging to closed interval 1 comma infinity open. So this is the answer for this. Now you can generalize also. If the greatest integer x is greater than equal to n, then we can say x belongs to closed interval n comma infinity. So this is the result that we have derived here, or we can say verified here. Now if greatest integer x is greater than 1, instead of greater than equal to, we have greater than 1. So we can say if it is greater than 1, it will be greater than or equal to 2. So in that case, the result above can be directly used, and the answer will be closed 2 to infinity. And in general, greatest integer x is greater than n will mean n plus 1 closed to infinity, using the above result. Then we have the case of less than equal to. If greatest integer x is less than equal to 1, once again we'll break into cases. Since greatest integer x is integer, so less than equal to 1 means it will be 1, or it will be less than that 0, or less than that minus 1, and so on to the lower side. Now each of them we can solve. The first one gives closed interval 1 to open 2. Second one gives x belonging to 0 closed to 1 open. Third one gives minus 1 closed to 0 open, and so on. Now if you mark them on the number line, you can very easily see that these intervals are in succession towards the lower side, that is towards minus infinity, starting from open to, right? So that is why we can write the answer taking the union of all this as x belongs to minus infinity comma 2 open. So that is how you get the answer. So you can generalize now. If greatest integer x is less than or equal to n, then we can say x will lie from minus infinity till n plus 1 open. So that is how the answer will look like in this case. Then we have the case of greatest integer x less than 1. Now in this case it is less than 1. So it is less than or equal to 0. And hence you can use the result just in the earlier case, fourth case. Answer will be minus infinity to 1 open open. So we can generalize if greatest integer x is less than n, then x will belong to the interval minus infinity to n open interval both ways. So these are the 5 cases. Now we can summarize these here, and then we have a few more cases. For example, since we know that greatest integer x is an integer, it belongs to the set of integers. So if you put another bracket over it, it will not make any difference. It will be still the greatest integer since it is an integer. So putting a number of brackets like these will not change it. It will be the same number. Next is greatest integer of x plus n is greatest integer x plus n, where n is an integer. And using this, you can write the result like this in terms of 3 numbers x, y, and z. Their greatest integers will be separated as shown here. Then comes minus of x greatest integer. It has minus of greatest integer x value if it is integer, and minus of greatest integer x minus 1 if x is not an integer. This can be observed or verified through an example. So if you take the number x as minus 5, it is equal to minus of greatest integer 5, since minus 5 is an integer. But then if you take the number which is not integer like minus 5.37, then we know its answer will be minus 6, and through this result it will be minus of greatest integer 5.37 minus 1, which again yields minus 6. So it is verified, so we can go ahead. So next we talk about fractional part function, which is defined as x minus greatest integer function x. This is because every number x can be broken up into 2 parts. One is the greatest integer function and second is the fractional part. Now, using the above result also we can write fractional part x is x when x belongs to 0 to 1, as x minus 1 when x belongs to 1 to 2, 1 closed to 2 open, and fractional part can also be written as x minus 2 when x belongs to 2 closed to 3 open, and so on. This is due to the definition given above. Next, we can have fractional part of fractional part x will be nothing but fractional part of x. Since fractional part of x we know is a fraction between 0 and 1, so that's why. But if we have fractional part of greatest integer, it will be 0, and if we have greatest integer of fractional part, even that will be also 0. These are important results which simplify our questions in so many cases. Now, minus of x fractional part will be 1 minus fractional part x. This is when x is not an integer, and it will be 0 if x is an integer. This also we can verify through an example here. We can take a number like minus 1.2. We know 1 minus fractional part of 1.2 will get you 1 minus 0.2, which is 0.8, which is using this result, and also otherwise you get the same answer. So we can say the result is verified. The next result will be x plus n fractional part. It is equal to fractional part of x if n is an integer. This is also a very, very important result we use in solving questions. Next, we talk about the fractional part function, whose graph is as shown here. You can see the value of y is between closed 0 to open 1, and it is true for all x. So domain is x belongs to R, and the range y, it belongs to the interval closed 0 to open 1. This is very important information. We will be utilizing it later on in solving questions. So let's revise these results in respect of greatest integer function and fractional part function as we have studied in detail, and we can solve the questions now. Now these are the questions in front of us. Let us take up the first question first and go over to the solution. Now in the first question you can see this is a greatest integer, which is an integer, so fractional part of that will be 0. So similarly, second term also has the similar format, it is also 0. So we are going to get 0 plus 0 less than 2 minus greatest integer x. So in the next step, you can say greatest integer x is less than 2. This kind of inequality we have seen. greatest integer x is less than equal to 1 is what it means, and hence x belongs to minus infinity to 2 open interval. So that is how quickly you can solve this question. Let's go then over to the next question, which is question number 2. In question number 2, you can see we have got so many greatest integer marks here. We know all of them can be separated using the property that we have studied. So we can write them as shown here in discrete terms. All of them can be separated like this. And the next step will be 4 times greatest integer x plus 2 equals to 6. So 4 times greatest integer x is equal to 4. Greatest integer x therefore is equal to 1, and therefore x belongs to closed 1 to 2 open. So this is going to be the answer for this particular question. Let's go to question number 3 then. In the question number 3, you can see we got an inequality like this. It's a quadratic inequality. You know how to split the middle term and factorize it. So that's what we are going to do here. We'll factorize using the splitting the middle term method. We get two factors now. Greatest integer of x minus 1 is one factor, and greatest integer of x minus 4 is the second one. And that is how you get the inequality like. Now using the wavy curve method, now we have got a video on this channel. So if you need, you can just watch it and be updated. Anyway, the answer is going to be 1 less than equal to greatest integer x less than equal to 4. And this will get you the answer quickly using this result which I am writing now. N1 is less than equal to greatest integer x is less than equal to N2. Then x belongs to N1 closed to N2 plus 1 open interval. So here the answer accordingly is going to be x belonging to 1 closed to 5 open. This is the answer. Now you can solve it alternatively also, as we have studied here. You can break it up into two inequalities. Greatest integer x is greater than equal to 1 and greatest integer x is less than equal to 4. Now their solutions will be closed 1 to infinity and minus infinity to 5 open. Taking the intersection of both of these, you get once again the same answer, 1 closed to 5 open. Although you got a one new result here, which also you can note down. So let's go over to the next question, which is question number 4. In question number 4, we can see we have fractional part x squared minus fractional part x minus 2 is greater than 0. Once again, splitting the middle term, we can get the two factors, two linear factors. We'll split the middle term like this. So you get the two factors as fractional part of x minus 2 and fractional part of x plus 1 greater than 0. Once again, using the wavy curve method, you get fractional part of x is either less than minus 1 or it is greater than 2. But we know about the fractional part function. We know its range. It belongs to 0 closed to 1 open. So it just cannot be less than minus 1. And it can also not be greater than 2. So rejecting both of these, we can say there is no such x or x belongs to the null set phi. We go over to the fifth question now. Here we can see first two terms can be split into discrete terms, and the third, this one becomes 0, being fractional part of greatest integer. So your equation becomes 2 times greatest integer x minus 1 is greater than equal to 1. So that 2 times greatest integer x is greater than equal to 2 or greatest integer x is greater than equal to 1. Hence x belongs to closed 1 to infinity. So that is how the answer to this question. Now the sixth one is the most important question here. In this question you can see the first term is okay. In the second term we have fractional part of greatest integer. So that can become 0. And the right hand side is fractional part of fractional part. So we start by writing x plus greatest integer x plus. Now you can see this part is fractional of greatest integer. So it is going to be 0. You write 0 here. And right hand side is fractional part of fractional part. You can just write singly fractional part of x plus 153, as we know. We have studied this result. And in the next step, we write x plus greatest integer x equals 6 times fractional part x. Because fractional part of x plus integer is nothing but fractional part of x. That also is a property. Now, x can be split as greatest integer x plus fractional part x. So you have these two terms plus greatest integer x equaling 6 times fractional part x. Collecting the terms, like terms on the two sides, you will have 2 times greatest integer x is equal to 5 times fractional part x. Now this equation contains both of these, fractional part as well as greatest integer. So we use a technique like this. See, we write fractional part is 2 by 5 of greatest integer x, and we know fractional part is between 0 and 1. It can never be negative, it can never be more than 1. And secondly, we know that greatest integer x is nothing but an integer. Using these two things, we can just make a column here, and we can first mark them as greatest integer x, one column. Second is fractional part x, second column, and sum of them will be equal to x. This we know very well. Now fractional part x, we know we have found is in our question 2 by 5 of greatest integer x. Now we can start our working here, which is a very neat working, very useful. We say greatest integer x is going to be an integer, so it can be 0, 1, -1, 2 or -2 and so on. Only integer values, x may be whatever, but greatest integer x will be always an integer. Now we got a relation with fractional part also, so we can now decide what the value of fractional part will be in each case. In first case it will be 0, so 0 plus 0 gets you 0, which is the answer for this question. In second case, when greatest integer x is 1, the fractional part it becomes 2 by 5. Now this is acceptable value, it lies between 0 and 1, we will accept it, and adding them we get the answer, which is 7 by 5. In the third case, when greatest integer x is -1, fractional part becomes -2 by 5, which is not acceptable. It is not between 0 and 1, so it will be rejected. Then we go to the next value of greatest integer x, which is 2. For that, we get 4 by 5 as fractional part, which is also acceptable. Adding them, you get the answer as 14 by 5, which is an acceptable answer. Next one, -2, when you take that, you get fractional part as negative of 4 by 5, which is not acceptable since it is not between 0 close to 1 open intervals. It is also rejected. Next, we take the value of greatest integer x as 3 also, but then fractional part comes out as 6 by 5, which is more than 1. It is not between 0 close to 1 open, so it is rejected. Now, any other values will not give us any more answers, so the only three answers we are going to get here are these three. So finally, the answers are 0, 7 by 5 and 14 by 5. Thanks for watching this video. Hope you learned a lot from this. Keep watching, subscribe the channel. See you soon.